EKG Analysis and Exercise Effect on Heart Rate. So part 1 says to define the terms in the content table. So here's my website. I'm on it, and then my paper. So I'm going to define these terms. So for EKG paper, I put it's a paper to trace like ECGs. The horizontal side records time with block marks of the top indicating 3-second intervals, and each second is marked by 5 large grid blocks. And each large block equals 0.2 seconds. The vertical records ECG voltage. There are two large blocks equal 1 millivolt, and each small block equals 0.1 millivolt. The large blocks have 5 small blocks, and they represent 0.04 seconds. EKG nomenclature. These contain waveforms that indicate electrical events during one heartbeat. These are P, Q, R, S, T, and U. They are with respect to lead. P is the first one, and it is usually a positive waveform. It indicates atrial depolarization. QRS follows P. It normally begins with a downward deflection, Q, a larger upward, R, and then downward, S wave. QRS complex represents ventricular depolarization and contraction. Number 3, EKG interpretation. This uses an 8-step procedure: rhythm, rate, P wave, PR interval, QRS duration, T wave, QT interval, and SC segment. Number 4 is rhythm. This is a repeated pattern. So like it goes up and down, so it's a repeated pattern that just keeps going. Heart rate, how many times your heart beats per minute. P wave, it is generated by an impulse from the SA node in the right atrium, and it goes across the atria. It is usually smooth and rounded, and the P wave represents atrial depolarization. PR interval, time from where P begins until the beginning of the QRS complex. So it's from where the atrial depolarization begins to the start of ventricular depolarization. Next, we have QRS complex. It indicates ventricular depolarization. We have the T wave. It is the repolarization of the ventricles, and it follows the QRS complex, and it is typically upwards. Next, we have the QT interval, and this is the time for ventricular activity, including depolarization and repolarization. It is measured at the beginning of the QRS complex to the end of the T wave. And then lastly, we have the ST segment, U wave. It is the early part of repolarization. It is the line that forms the end of the QRS complex to the beginning of the T wave. Normally it is flat to the baseline, and then an elevated ST can indicate an acute myocardial infarction or other cardiac conditions. Okay, so now it says to choose 4 of my abnormal EKGs, and then to describe what the difference is between each of them compared to my normal EKG. So this is my normal EKG. It's the normal sinus rhythm. So first I'm going to compare it to the sinus arrest. So the normal sinus rhythm is regular. Its rhythm is regular. Its rate is normal. and then when it is normal, it has a steady rate. You can see it has a steady rate, a steady pattern. So compared to the sinus arrest, the rhythm is irregular because there's a pause in there. The rate is normal to slow, and then it's a pause in electrical activity. It's when the SA node isn't working right. So you can see there's a big, it goes, and then it has a big pause in it, and then it goes. Compared to this one, it just has a steady rhythm. Okay, so next I'm gonna do my atrial flutter. So the atrial flutter is regular or irregular. It has a fast rate of 250 to 300 beats per minute. It is rapid depolarization occurring 2, 3, 4 times per QRS complex. It is when the atria does not adequately pump blood to the ventricles. So you can see it's going really, really quick. Like, it goes and then it goes up and then it goes up. It's really quick, and the lines are like smushed together compared to this one, and it's steady, and it goes and then it goes up and then it goes up. It's steady. But next is my junctional tachycardia. The rhythm is regular. The rate is fast with 100 to 180 beats per minute, and it occurs when a junctional rhythm exceeds 100 beats per minute. These are all smushed together too, compared to this one, where it's just kind of spaced out a little bit. Yeah. And then I'm gonna do my ventricular fibrillation. It's kind of just a bunch of little bumps. So its rhythm is highly irregular, its rate is unmeasurable, and it's when ventricles are not contracting and when blood is not circulating. So it kind of just goes at a little baby like rate. It just goes. There's no up. It just goes. Like, compared to this one, it goes up and then it goes and it goes up. So yeah, those are my 4 comparisons to the normal EKG. Part 2. Okay, so apparently my tables did not print out, so I'm going to just, I put it on paper pretty much. So I did my exercise. I did jumping jacks, and I set a timer for 10 minutes, and I recorded every minute, and yeah, so here's my graphs I constructed. So my first trial was 84, my second trial was 84, and my third trial was 96. I think I was getting a little nervous about the lab, but it's okay. So first minute into my exercise, I was at 128 beats per minute. 2 minutes, I was at 156. 3 minutes, I was at 158. 4 minutes, I was at 160. And 5 minutes, I was at 190. So now it's recovery time. So 6 minutes, I was at 55. This is doing 30 seconds intervals. So I was at 55. And then 6:30, I was at 52. 7, I was at 52. 7:30, I was at 49. And then 8, I was at 48, and then 8:30, I was at 46, and then 9, I was 46, 9:30, 46, and 10:46. So as you can tell, I did my graph, and then these were my this was my exercise time, and then this was my recovery time, since it was 30-second intervals. So my highest heart rate was at 5 minutes, and I was at 192 beats per minute. Did you return to your resting rate during recovery? Yeah, I did. It took about 3 minutes. And then, why did your heart rate change during physical activity? Because when you're doing physical activity, your heart starts pumping faster, and you get more tired, and yeah. And then it says, why did your heart rate change during recovery? Because you're resting, you're not doing anything, you're just sitting here, so it'll return back to its normal heart rate. Post-lab questions. Question 1. What is the function of the cardiovascular system? So it pumps blood, it delivers oxygen, nutrients, and it removes unwanted substances. Question 2. What is blood? What makes up blood? So blood is a fluid that makes up white blood cells, red blood cells, plasma, and platelets. Question 3. Compare and contrast diastole and systole. How are they similar? How are they different? So I put their timing is different because D is at the diastole is after systole, and it is systole is active, whereas diastole is resting. And then I put both are part of the cardiac cycle, and they both have chambers. Question 4. Compare and contrast pulmonary circuit and systemic circuit. How are they similar? How are they different? So I put their similarity is that they both transport blood, and then their difference is that the pulmonary is low in oxygen and high in carbon dioxide, whereas systemic is high in oxygen and low in carbon dioxide. Question 5. What information can we learn from an electrocardiogram? Well, we can see the activity, and we can help our overall health, because if we see any, we can catch any abnormalities if we have any with an electrocardiogram.